Hi to all, this is my third class of chapter 5 Lines and Angles. Today I am discussing about intersecting lines, transversal, angles made by a transversal. Here you have two pictures. One is a racket, another is a scissors. Can you find out anything in common in these two figures? Let me see these girls. All these girls, you can see they are crossing each other. Similarly here the scissors, it also crosses. This gives the idea of intersecting lines. Let us see. Let me draw two lines. These two lines crossing here. So we can call these two lines as intersecting lines. That one line touches the other line. Here, let the lines be L and M. This L and M have a common point. Let it be O. That means O lies in L or O lies on M also. So this O has a name. It is called point of intersection. So here O is the point of intersection. So we can define point of intersection as two lines L and M intersect if they have a point in common. They have a common point, then we can call that those lines are intersecting. And that common point O is the point of intersection. That common point is called the point of intersection. Here L and M are intersecting. O is the point of intersection. So please note it down. Here is a figure. You can find out many intersecting line segments. For example, BC and EC intersecting at C. Similarly, BA and AP intersecting at P. Now, you can find another 10 pairs of intersecting line segment using this figure. Do it. Here you have two pictures. One is a wooden door, another is a bridge. Here you can notice so many planks. Here so many planks. Many planks are there, intersected by a single plank. Now here also you can see these two pillars and so many beams join these two pillars, or you can say these two pillars intersecting many beams. Similarly here this rope, here also many ropes you can see. This gives the idea of a transversal. Now let us see what is a transversal. Then what's a transversal? Transversal is a line that intersects two or more lines at distinct points is called a transversal. Let us draw a transversal. Here L and M are two lines. Then it intersected by a line P. So here P intersect 2 points, so we can call P is a transversal. That is, P is a transversal to the lines L and M. Look at the figure. Here P intersects line L, P intersect line M. Can you say P is a transversal of L and M? Here P is not a transversal of L and M. Why? Here you see, here P intersecting L and M at distinct points, but here in the same point it is intersecting. So P is not a transversal to L and M. So you can write the line P is not a transversal. Now let us take angles made by a transversal. Here M and L are two lines and P is the transversal. Now how many angles are made by P with M and L? You can find out 8 angles made by transversal P to line L and M. Let it be angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7 and angle 8. Now categorize these angles. Now what are the angles interior of L and M, or the interior angles are 3 is interior, then 4, then 6, then 5, or 3, 4, 5, 6, all these angles we can call it as interior angles. Now what are the exterior angles? Here angle 1 is exterior, angle 2 is exterior, angle 8 is exterior, and angle 7 also exterior. So this angle we can call it as exterior angles. Exterior angles are angle 1, angle 2, angle 7 and angle 8. Now can you find out the angles with different vertices and on the same side of the transversal and having corresponding positions, that is, one is above, another is below. The angles which satisfy these three conditions, can you find out those angles? One I will show you. This angle 2 and angle 6. These two angles having different vertices are on the same side of the transversal. One is above, another is below. Three conditions satisfied. Can you find out any other? You can find out on the same side angle 4 and angle 8. Next pair, can you say? Yes, it is angle 1 and angle 5. And one more pair you can say, it is angle 3 and angle 7. This type of angles is called corresponding angles. The corresponding angles are angle 1, angle 5, angle 2 and angle 6, angle 3 and angle 7, and angle 4 and angle 8. One more condition you can say, one angle is exterior and its corresponding angles will be interior. That is why it is called the corresponding positions. It holds corresponding positions. Now find out the pairs of angles having different vertices lying opposite to the opposite side of the transversal, and third in between line L and F, that means interior. These three conditions satisfying angles do find out. One pair I can say angle 3 and angle 6 having different vertices, opposite sides of the transversal or alternate side of the transversal, and they are both are interior of the line M and N. This kind of angles we can call it as alternate interior angles. One pair angle 3 and angle 6 are alternate interior angles. One more pair you can say, that is angle 4 and angle 5. Pairs of alternate interior angles are angle 3 and angle 6, angle 4 and angle 5. In the same way, can you find out alternate exterior angle? The same condition you can follow, but there should be exterior of the line L and M. One pair I will show you. Angle 1 is exterior and its alternate exterior angle is angle 8. Then what will be the other pair of alternate exterior angle? Yes, it will be angle 2 and angle 7. Pairs of alternate exterior angles, angle 1 and angle 8 and angle 2 and angle 7. Now can you find out the angles which are interior and same side of the transversal? What are they? One pair I will show, angle 3, angle 5. These two angles are on the same side of the transversal and interior of the transversal. Interior of lines L and M. This type of angles we can call it as pairs of interior angles on the same side of the transversal. One more pair you can find out here, that is angle 4 and angle 6. That is pairs of interior angles on the same side of the transversal are angle 3 and angle 5, angle 4 and angle 6. Draw this figure and write all the name of the angles, and this will be used for higher classes also. Now I have some questions for you. Name the pairs of angles in each figure. Look here, angle 1 and angle 2. Same side, different vertices. One is upside, another is below. Draw this figure and write the name of the pairs of angles. The first one is corresponding angles, pairs of corresponding angles. You can write angle 1 and angle 2 are pairs of corresponding angles. Now here you write angle 3 and angle 4 are, write the name of those angles. Now what is 11 and 12, do you remember? These two are opposite rays and another one line. So 11 and 12, yes, it is pairs of linear pair of angles. Linear pair of angles you write. This is question number 2 of exercise 5.2. In the adjoining figure, identify the pair of corresponding angles, the pair of alternate interior angles, pair of interior angles on the same side of the transversal, and vertically opposite angles. These vertically opposite angles I discussed in the last class. So do this problem. That is all for today's class. Have a nice day.